Hello, it's Mrs. Scarple again, and in our previous video we talked about what makes a function, and for a function every input value is paired with exactly one output value. Now when it comes to functions, the set of all input values is defined as being the domain. So domain goes with input values. The range of a function is the set of all possible output values. So range goes with output. And we talked in the other video about the input values are your x values and your output values are your y values. So if we take a look at this function machine, we will input this -2. We'll plug it in for the x, and when we take 3 times -x, out comes -6. So your input is x, your output is y. So we can identify domain and range by looking at our graphs, and if it's a set of points, we will list numbers. So the domain of graph A is the set of x values. I believe it looks like this in the book. X values of, so we have an x value for this point over here on the left of -3. This next point on the left has an x value of -1. Then we have an x value of 1. And we have an x value of +3. So that's our domain. Our range, again, those are the output values. That's going to be the y values. So that would be the y value that goes with each of these points. So we have a y value of +3, a y value of +1, a y value of -1, and a y value of -3. So these are my sets. X values of -3, -1, 1, and 3. My range are values 3, 1, -1, and -3. Now something else I'm going to mention, in an answer key, these would be listed in increasing order. So from the smallest value to the largest value. It wouldn't necessarily follow the order of the graph from left to right. I personally won't be so picky with my students on this as long as you list the values within domain and range. Now on graph B, you see that we have this curve. So all of the points that are on this curve actually are represented in our domain and range as well. We couldn't possibly list every single one of those points, so we have to use some inequality symbols. So the domain, I start with, I'm going to put X and then I'm going to put this bar. I notice that my lowest X value is at -1. And I notice that my largest X value is at +3. Since domain is X, I'm going to say that X has to be more than, and I'm going to say equal to, because this is a filled in circle on the end. Because it's filled in, because it's solid, we have this equal to -1. But this X is also less than, because it's to the left of 3. It's less than or equal to, because it's filled in, because it's filled in, I need this equal to positive 3. So that would be my domain. My range, that's my outputs, are the y values. So I'm looking at, well, what's the highest point of my graph? What's the lowest point of my graph? My lowest point is at negative 3. So I know that y has to be more than or equal to, because this is filled in at the bottom, negative 3, but it's also less than or equal to, and I say equal to because, again, that point is filled in, positive 2. Now, if we had something, I'm just going to add a quick graph here. Find my browser that has my graphs. Here we go. If I have a graph that looks like I have an open circle, and then I am going down to this point that has a closed circle, and I need to write my domain and range. So for my domain, I'm still looking at the x values. My smallest x value is at negative 5, but because this is an open circle, I'm not going to say that x equals negative 5. I'm just going to say that x is greater than negative 5. And that x is, my largest x value is 2, so I'm going to, and because it's filled in, I'm going to use that equal to 2. So my domain is x values greater than negative 5, less than equal to 2. And we call this what is called a compound inequality because it's two inequalities in one statement. So let's do the same thing with range. Again, range is the y values. So we have a y value, our smallest y value is at 1, but that 1 is included. So I need to underline my inequality. So y is greater than or equal to 1, but that y is also less than or equal to 5. Well, actually not equal to because it's an open circle. Jumping ahead of myself here. So it's just less than 5. So when you have an open circle, you're not going to include that underline. You're not going to include the equal to. When it's filled in, the inequality needs to be underlined. Now the variables in our functions are also defined as being independent or dependent. Independent variables are the variables that represent the input values of a function. Now, what helps me remember that the independent goes with input is that they both start with the prefix in. And then if I can keep in mind that input is my x, that helps me with my equations, that my independent variable is going to be my input. That means the dependent variable is going to be my output. And again, that output variable is y. So when we have an equation, y equals negative x plus 10, the x, that input, is your independent variable, and then the y is your dependent variable. So here we have the function c equals 6t plus 8, represents the cost c for t-shirts plus shipping. Identify the independent and dependent variables. So the independent is the input, which is X. The dependent is the output, which is Y. Now, even though this isn't in using X and Y, we can look to see, well, what variable is in the position that we're used to seeing the X? And in this case, it's the T. So we can say independent variable is T, and we can say dependent variable is C. So our cost is dependent on the number of t-shirts we order. Now, if we know our specific domain, we can find our range. So I'm going to create a table here. I'm going to list my domain in one row of my table so that I can find my range. So my domain is 1, 2, 3, 4, and 5. To find my range, I need to take these domain values, these input values, and plug them in for T. I need to substitute for T to get my output. So I have C is going to equal 6 times 1 plus 8. Well, when T is 1, that's 6 times 1 is 6, plus 8 is 14. So when our domain value is 1, our range value is 14. My next domain value is 2, so 6 times 2 plus 8. 6 times 2 is 12, plus 8 is 20. So when the domain value is 2, the range value is 20. C, when T is 3, 6 times 3 is 18, plus 8 is 26. So when the input is 3, the output is 26. When T is 4, 24 plus 8 is 32. So when the input is 4, the output is 32. And finally, when the input is 5, 6 times 5 is 30, plus 8 is 38. So when the input is 5, the output is 38. So our range, when our domain is 1, 2, 3, 4, and 5, our range is 14, 20, 26, 32, 38. And that is how we work with independent and dependent variables, which work with our inputs and our outputs.